Okay, section B number 10, it was coming from algebra of polynomials and also inequalities. So let us see how we go about it. So number 10 part A, it was they gave you the polynomial, they wanted you to get the value of P. So you let your f of x be the polynomial. So they told you that it's divisible by this. So there we are going to use the factor theorem, that if this is divisible by this, then f of the root gives you 0. So f of 4 will be equal to a 0. Substituting there. Equals to 0. Then the value of p from there, we shall get minus 12. So meaning now my function there, my f of x minus 12. Then they're asking you, hey, solve. So to solve this, now they want us now to solve this equals to 0. This one is start by long dividing to get the other two factors. So this goes here, x squared, x cubed, minus 4x, then you squared, you subtract. So this will give us 0, this will give us 4x squared, minus 13x, minus 12. So this goes here, plus 4x times this, then minus 16x, and when you subtract, get 3x minus 12, and this x goes there, 3x minus 12. If you want to see the details of how we long divide, please visit the playlist. So meaning, the whole of this is now going to be, now, my x cubed minus 12 is going to be now, this times this plus the remainder, which is 0. So x minus 4. So then we factorize this. We factorize that is that we have the two factors for this is 3 and 1. So if we equate it to 0, like it was in this case, all of this is 0. You could able to see that either x is negative 3, negative 1, and 4. So we have solved that. When we come to part B, it was from inequalities. So we start by bringing the other thing to the left. Over x plus 3, then minus x over 2 greater or equal to 0. Then we multiply, cross multiply. We having then minus the whole thing over greater or equaling to 0. So from there we simplify. This will give us x squared minus 5x minus 36 greater or equal to 0. So we factorize that, we get x minus 9 into x plus 4 over These two you can multiply to the other side to get lost, or you can take it there, greater or equal to 0. But we say that something to be greater or equal to 0, greater than 0, has to be a positive. So we are going to look for positive signs in our table of critical values. So getting critical values, we equate this to 0, and this to 0. So our critical values have x equals to -4, -3, and 9. Then from there, we can able draw our table, analyze the critical values. Let's put here our x below the smallest, between the smallest, between this and this, then above the biggest. We are looking for the sign of our function. Which function? This function here. So look for the easiest range where we have 0. So 0 in this range. So when I put here 0, I want to see which sign is it. When I put here 0, I have -9 times times +4. So up I have a negative. When I put here 0, I have a positive. So negative divided by a positive, I'll be having a minus. So in inequalities, once that one is minus, they are going to alternate. So this will be positive, this will be negative, this will be a positive. To see the details, visit the playlist, then you go to inequalities. You'll see how we are coming to this. So now our solution, remember, we are looking for the positives. We have two positives, this and this. So now our solution set, we are going to be having -4, -4 less x, less -3, and x above 9. Because this had greater or equal to, which one was coming for denominator was this. So we have this and that. And so those are our solutions for that inequality. Okay, let us move to number 11.